we'd have been proud to have had in Britain. And they all came from Basel.
You might have great minds like Newton and Leibniz who make these fundamental breakthroughs, but you also need the disciples who take that message, clarify it, realise its implications, and then spread it wide.
The family were originally merchants, and this is one of their houses. It's now part of the University of Basel, and it's been completely refurbished, apart from one room, which has been kept very much as the family would have used it. Dr. Fritz Nagel, keeper of the Bernoulli archive, has promised to show it to me. If we can find it.
No, we are in the wrong floor.
Wrong floor, okay,
Wrong floor.
Right. Oh, look, are these free apples? We can take an apple?
No, wrong mathematician. Eventually, we got there.
So this is where the Bernoullis would have done some of their mathematics of an evening.
I was really just being polite. I'm not sure we should have bothered. The only thing of interest was an old stove.
Now, of the Bernoullis, which is your favourite?
My favourite Bernoulli is Johann I. He is the most smart mathematician. Perhaps his brother Jakob was the mathematician with the deeper insight in the problems, but Johann found elegant solutions.
The brothers didn't like each other much, but both worshipped Leibniz. They corresponded with him, stood up for him against Newton's allies, and spread his calculus throughout Europe.
Leibniz was very happy to find two gifted mathematicians outside of his personal circle of friends who mastered his calculus and could distribute it in the scientific community. That was very important for Leibniz.
Yeah. And important for maths too. Without the Bernoullis, it would have taken much longer for calculus to become what it is today, a cornerstone of mathematics. At least that is Dr. Nagel's contention, and he's a great Bernoulli fan. Tonight, he's arranged for me to meet Professor Daniel Bernoulli, the latest member of the family, whose famous name ensures he gets some very odd emails.
The other one which I got was Professor Bernoulli, can you give me a hand with calculus?
Yes, exactly. To find a Bernoulli, then you expect them to be able to do some calculus.
But this Daniel Bernoulli is a professor of geology. The maths gene seems to have truly died out. And during our very hearty dinner, I found myself wandering back to maths. It's a bit unfair on the Bernoullis to describe them simply as disciples of Leibniz. One of their many great contributions to mathematics was to develop the calculus to solve a classic problem of the day. Imagine a ball rolling down a ramp. The task is to design a ramp that will get the ball from the top to the bottom in the fastest time possible. You might think that a straight ramp would be quickest, or possibly a curved one like this that gives the ball plenty of downward momentum. In fact, it's neither of these. Calculus shows that it's what we call a cycloid, the path traced by a point on the rim of a moving bicycle wheel. This application of the calculus by the Bernoullis, which became known as the calculus of variation, has become one of the most powerful aspects of the mathematics of Leibniz and Newton. Investors use it to maximize profits. Engineers exploit it to minimize energy use. Designers apply it to optimize construction. It has now become one of the linchpins of our modern technological world. Meanwhile, things were getting more interesting in the restaurant.
My second surprise, may I introduce Mr. Leonhard Euler? Daniel Bernoulli.
Leonhard Euler, one of the most famous names in mathematics. This Leonhard is a descendant of the original Leonhard Euler, star pupil of Johann Bernoulli.
I'm the 9th generation and the 4th Leonhard in our family after Leonhard Euler the first, the mathematician.
Okay, and yourself, are you a mathematician?
Actually, I'm a business analyst, but I can't study mathematician with my name.
Everyone will expect you to prove the Riemann hypothesis.
Perhaps it's just as well that Leonhard decided not to follow in the footsteps of his illustrious ancestor. He'd have had a lot to live up to.
I'm going in a boat across the Rhine, and I must say I'm feeling a little bit worse for wear this morning. Last night's dinner with Mr. Euler and Professor Bernoulli degenerated into toasts to all the theorems that the Bernoullis and Eulers had proved, and by God, they proved quite a lot of them. Never again.
I was getting disapproving glances from my fellow passengers as well. Luckily, it was only a short trip. Not like the trip that Euler took in 1728 to start a new life. Euler may have been the prodigy of Johann Bernoulli, but there was no room for him in the city.
If your name wasn't Bernoulli, then there was little chance of getting a job in mathematics here in Basel. But Daniel, the son of Johann Bernoulli, was a great friend of Euler and managed to get him a job at his university.
But to get there would take 7 weeks, because Daniel's university was in Russia. It wasn't an intellectual powerhouse like Berlin or Paris, but St. Petersburg was by no means unsophisticated in the 18th century. Peter the Great had created his city very much in the European style, and every fashionable city at the time had a scientific academy. Peter's Academy is now a museum. It includes several rooms full of the kind of grotesque curiosities that are usually kept out of the public display in the West. But in the 1730s, this building was a centre for groundbreaking research. It's where Euler found his intellectual home.
I'm sure that there could never be a more contented man than me. I earn my living.
Many of the ideas that were bubbling away at the time, calculus of variation, Fermat's theory of numbers, crystallise in Euler's hands. But he was also creating incredibly modern mathematics, topology and analysis.
Much of the notation that I use today as a mathematician was created by Euler, numbers like E and I. Euler also popularised the use of the symbol pi.
He even combined these numbers together in one of the most beautiful formulas of mathematics. E to the power of I times pi is equal to -1, an amazing feat of mathematical alchemy.
His life, in fact, is full of mathematical magic. Euler applied his skills to an immense range of topics, from prime numbers to optics to astronomy. He devised a new system of weights and measures, wrote a textbook on mechanics, and even found time to develop a new theory of music. I think of him as the Mozart of maths, and that view is shared by the mathematician Nikolai Vavilov, who met me at the house that was given to Euler by Catherine the Great.
Euler lived here from 66 to 83, which means from the year he came back to St. Petersburg to the year he died. And he was a member of the Russian Academy of Sciences and the greatest mathematician.
Right.
This is exactly what it says.
What is it now?
Now it's a school, actually.
A school?
Yeah.
Should we go in and see what's...
Okay, yeah.
I'm not sure Nikolai entirely approved, but nothing ventured.
Perhaps we should talk to the head teacher and see whether we can...
Да. Здравствуйте, мы пройдем к директору.
The head didn't mind at all. I rather got the impression that she was used to people dropping in to talk about Euler. She even had a couple of very able pupils suspiciously close to hand.
These 2 young ladies are ready to tell a few words about this scientist and about this very building.
They certainly knew their stuff. They'd undertaken an entire classroom project on Euler, his long life, happy marriage, and 13 children. And then his tragedies. Only 5 of his children survived to adulthood. His first wife, who he adored, died young. He started losing most of his eyesight.
So for the last years of his life, he still continued to work, actually. He still continued his mathematical research.
Yeah, I read a lovely quote that said, now with his blindness, he hasn't got any distractions and he can finally get on with his mathematics.
Yeah, this is what he said, yes.
Very positive attitude.
Actually,
It was a totally unexpected and charming visit. Although I couldn't resist sneaking back and correcting one of the equations on the board when everyone else had left. To demonstrate one of my favourite Euler theorems, I needed a drink. It concerns calculating infinite sums, the discovery that shot Euler to the top of the mathematical pops when it was announced in 1735. Take 1 shot glass full of vodka and add it to this tall glass here. Next, take a glass which is a quarter full or a half squared and add it to the first glass. Next, take a glass which is a 1/9 full or a 1/3 squared and add that one. Now, if I keep on adding infinitely many glasses where each one is a fraction squared, how much will be in this tall glass here? It was called the Basel problem after the Bernoullis tried and failed to solve it. Daniel Bernoulli knew that you would not get an infinite amount of vodka. He estimated that the total would come to about 1 3/5. But then Euler came along. Daniel was close, but mathematics is about precision. Euler calculated that the total height of the vodka would be exactly pi squared divided by 6. It was a complete surprise. What on earth did adding squares of fractions have to do with this special number pi? But Euler's analysis showed that they were two sides of the same equation. 1 plus a quarter plus a ninth plus a 16th and so on to infinity is equal to pi squared over 6. That's still quite a lot of vodka, but here goes. Euler would certainly be a hard act to follow. Mathematicians from two countries would try. Both France and Germany were caught up in the age of revolution that was sweeping Europe in the late 18th century. Both desperately needed mathematicians, but they went about supporting mathematics rather differently. Here in France, the revolution emphasised the usefulness of mathematics. Napoleon recognised that if you were going to have the best military machine, the best weaponry, then you needed the best mathematicians. Napoleon's reforms gave mathematics a big boost, but this was a mathematics that was going to serve society.
Here in the German states, the great educationalist Wilhelm von Humboldt was also committed to mathematics, but a mathematics that was detached from the demands of the state and the military. Von Humboldt's educational reforms valued mathematics for its own sake.
In France, they got wonderful mathematicians like Joseph Fourier, whose work on sound waves we still benefit from today. MP3 technology is based on Fourier analysis. But in Germany, they got, at least in my opinion, the greatest mathematician ever. Quaint and quiet, the university town of Göttingen may seem like a bit of a backwater. But this little town has been home to some of the giants of maths, including the man who's often described as the prince of mathematics, Carl Friedrich Gauss. Few non-mathematicians, however, seem to know anything about him. Not in Paris, qui s'appelle Carl Friedrich Gauss. No? Not in Oxford.
I've heard names, but I couldn't tell you.
No idea.
No idea?
No.
And I'm afraid to say, not even in modern Germany.
Me?
No? Okay.
I don't know.
You don't know? But in Göttingen, everyone knows who Gauss is. He's the local hero. His father was a stonemason, and it's likely that Gauss would have become one too. But his singular talent was recognised by his mother, and she helped ensure that he received the best possible education.
Every few years in the news you hear about a new prodigy who's passed their A-levels at 10, gone to university at 12, but nobody compares to Gauss. Already at the age of 12, he was criticising Euclid's geometry. At 15, he discovered a new pattern in prime numbers which had eluded mathematicians for 2,000 years. And at 19, he discovered the construction of a 17-sided figure which nobody had known before this time.
His early successes encouraged Gauss to keep a diary. Here at the University of Göttingen, you can still read it, if you can understand Latin. Fortunately, I had help.
The first entry is in 1796.
Is it possible to lift it up?
Yes, but be careful.
Yeah,
with
it.
It's really one of the most valuable things that this library possesses.
Yeah, I can believe that.
He writes beautifully.
It is aesthetically very pleasing, you know, even if people don't understand what this is. It is just beautiful to look at. So I'm going to put this down, actually. It's very delicate.
Yes.
The diary proves that some of Gauss's ideas were 100 years ahead of their time.
Well, here are some signs and
these
integrals.
Sort of integrals.
Very different sort of mathematics.
This was the first intimations of the theory of elliptic functions, which was one of his other great developments.